Geometry lesson 3-1. Start to look at some relationships between lines. Our first definition is the idea of parallel lines. Parallel lines lie in the same plane, which means they're coplanar, and they never intersect. This is the symbol we would use for parallel lines. And if I were to compare some parallel lines right here, I could say that these two are parallel to each other. No matter where they are, they're parallel to each other because they're in the same plane. That's parallel, parallel, parallel. As long as they stay in the same plane and they would never touch each other, that would be considered parallel. Now, what's different than parallel lines, but similar in the fact that they never touch each other, is the idea of a skew line. Now, skew lines are not coplanar, which means they don't lie in the same plane, but they still never intersect. So they're like this. These lines would be considered skew. This is not skew. This would be perpendicular to each other. These would be intersecting lines. But anytime there's space between them, they're not in the same plane, and they still never touch. This one goes up and down. This one goes front to back forever. They never touch. So this right here, that would be skew lines. They'll never touch. They're in different planes. All right? Even if they're like this, they're still never going to touch. So the difference between skew and parallel is the whole plane bit. Skew and parallel. A transversal is a line that intersects two or more coplanar lines. Now, I'm not talking about anything specific about these coplanar lines. Just anytime you have a set of lines like so, that are like this, maybe they're like this, just however, you have two lines that are in the same plane, and a third one goes across them. A third line or more, maybe there's more lines that are coplanar, all right, two or more, but there's one line that seems to intersect them all. When we had that, we'll create what we call corresponding angles. Corresponding is a really fancy word for matches. They're on the same corner on a different intersection is how I like to think of it. So here's a map of New York City, and on this map you can see there are quite a few lines. If I were to use this line, say right here, and this line right here, I could say that this line is the transversal. And the reason it's the transversal, because it's intersecting two coplanar lines. The coplanar lines are in the street. Now, corresponding angles, a moment ago I said corresponding angles are the same corner but on a different intersection. Here's a street corner right here, and here's a street corner right here. They're on the same corner, just different intersections. This street corner right here corresponds to that one right there. Again, same basic corner, just a different intersection. And this street corner here matches up with that street corner there. Okay? There would be a fourth one. This street corner matches up with that street corner. So that's the idea of corresponding. They're in a matching situation, just on a different intersection. And if we were to put in another street line right here, then we would actually end up with more corresponding angles. We would be able to say, oh, well, that corner matches up with this corner right here. And that corner matches up, corresponds to this one. And those two correspond to this corner. It's on the same one of that intersection. And this one matches up with the other two on the same location. So that's the idea of corresponding. Matching corners. Alternate exterior angles. Now we're going to look at a specific example of each one of these, but I want to get the definitions in first. The outside of two parallel lines, and they're on the opposite sides of the transversal. Right? Now we may not always have parallel lines, but they're on the outside of the lines that are being intersected by the transversal. And they're on opposite sides of the transversal. Alternate interior angles. They're in between the two parallel lines, typically they're parallel, and on opposite sides of the transversal. So we have a line that's crossing them, they'll be on opposite sides of it, but they'll be in between the intersected lines, and you'll see this in a moment. This is called consecutive interior angles, also known as same side. So they're on the same side of the transversal. They're still in between, or inside the two parallel lines, or the lines, but they're on the same side of the transversal. So here we have a situation with some parallel lines. All right, this is called the transversal, abbreviated as trans. This is the transversal right there. And these are the lines that are being intersected. If they truly were parallel, then we would put a symbol on them like this. We would put little arrows on them that state that they're parallel. Maybe they are, maybe they aren't. If there were more than one set of parallel lines, then I might have 2 arrows on one, and maybe there was another set over here like this, and I'd say that was parallel to that, so it would be different. All depends on how many arrows you have on there. Okay? But according to this, let's think about where the corresponding angles are. Remember, corresponding angles are the same corner, just a different intersection. So 1 is in the same location as 5. They are corresponding. 2 is in the same location as 6. 3 is in the same location as 7. So here's 3. There's 7. They're in the same location. And 4 is in the same spot as 8. So those are the corresponding or the matching angles. Now there's more to this than that, so I'm going to get rid of those symbols so that I can look at them some more without anything on it. Next, we have what we call the alternate exterior angles. Exterior meaning outside. Alternate meaning opposites. So the transversals down the middle, in order for it to be alternate, one has to be on one side of the transversal and the other one has to be on the other. And they have to be on the outside of the lines that are being intercepted by the transversal. So we're saying that the alternate exteriors are 1 and 8. There's 1, so this angle and this angle are alternate exterior angles. But they're not the only ones. Because right here we have 7 and 2. They're on opposite sides of the transversal and then on the outside of the 2 angles that are being intersected. Alternate interior angles. These are the angles on the inside. 3 and 6. 3 is on the opposite side of the transversal. So therefore those 2 would be considered alternates because they're on opposite sides of the transversal, and they're interior. They're between the 2 lines that are intersected by the transversal. Also, we would have 4 and 5. Those 2 are alternate interior angles because they're on opposite sides of the transversal, which is what the alternate refers to, and they're interior. And the last one we have is consecutive interior angles, also known as same side angles. They're on the same side of the transversal, so 4 and 6. We would have 4 and 6 are on the same side, but they're interior because they're between the 2 lines here. And 5 and 3 would be considered interior consecutive angles because they're on the same side of the transversal. Alright, so let's look at one more. This diagram, we want to know the corresponding angles. Which ones are on the same location but a different street corner. Now these are not parallel lines, obviously. They come together up here. So we aren't going to have measurements that are the same, but we can still look for the corresponding corner. This one, angle 1, this appears to correspond with angle 3. Angle 5 is in the same location as 7. Angle 6 with 8. And angle 2 with 4. So those would be considered the corresponding corners. This top left of that intersection. Bottom right of that intersection. Right? Same diagram, now the alternate exterior. Alternate meaning on the opposite sides of this transversal, so one's on top, one's on bottom. And they have to be exterior, on the outside. Angle 1 and angle 8. Angle 5 and angle 4. After we do the alternate exterior, we'll then work with the alternate interior angles. So they got to be on opposite sides of the transversal, 2 and 7. And 3 and 6. And the last one we would have is the same side or consecutive interior angles. They're on the same side of the transversal, so 6 and 7. They have to also be inside, and 2 and 3. And that's how we would describe the different relationships of the angles produced by a transversal. Remember, a transversal intersects two lines that are in the same plane, two or more lines. It's possible that there could be a third line, thus creating more angles that have relationships with each other.